Hi, my name is Bartola Garcia, and I'm currently a senior at Meredith College, majoring in biology and chemistry. My summer research project over this past summer dealt with the identification and extraction of Prodigiosin from Serratia marcescens and also synthesizing sulfanilamide in a lab setting. A little bit of background of this bacteria. The Serratia marcescens is a gram-negative bacteria that can cause nosocomial infections, which are infections that you catch in hospital settings. So because these bacteria live in such a setting, it's really hard to get rid of them once they give you an infection. And they're very resistant to any type of antibiotic that is tried on them. But the point of our whole experiment was that one thing that this bacteria does is that it produces this compound, this red compound called prodigiosin while it's growing. And so we wanted to extract this prodigiosin compound and use microbiological and organic chemistry techniques to make a module that can be applied in a small laboratory setting, like our institution, to teach students interdisciplinary skills. In my methods section here, you can see the type of instruments and techniques that we used to extract the prodigiosin once it was grown. And when we quantified it and identified the prodigiosin, we were able to tell from its structure where the peaks were and if we had successfully extracted it from the bacteria that we had grown. We also did an experiment where we were synthesizing sulfanilamide from basic compounds, and we were able to synthesize enough of it to make 2 antibiotic solutions. And one antibiotic solution was in DMSO, and the other one was in 1.2% ethanol. And we applied this antibiotic solution to bacteria and see if they were potent enough to be called antibiotics. Unfortunately, we found that these antibiotics that we had synthesized and the solution that we had made were not potent enough to be called antibiotics, and further work needs to be done on that. However, for the prodigiosin, we were able to successfully grow the bacteria and synthesize enough of this prodigiosin red compound to extract it from the bacteria. So having said this, because of this technique that we used for our sulfanilamide, even though the antibiotic solutions didn't work, we were able to increase the recovery yield of sulfanilamide by recrystallizing the solution and taking out or extracting more sulfanilamide from the solution than we had initially done when we first did the experiment. In conclusion, based off of this experiment in this module, this can be hopefully applied in the future at our institution for a module that will teach interdisciplinary skills that teaches both microbiological and organic chemistry techniques. Thank you for listening, and I appreciate your consideration.